See Lindelof videos, quotient rule, number 30. Here we have h of x is equal to f of x over x, and we're asked to find h prime at x. What we do know about this f of x is that it's non-specified, but we've been assured that it is differentiable. So assuming those two things, this is how I would go about this. First off, we have the quotient rule, right? So we're going to need some information, and we're going to need f of x. And it's really weird because f of x is equal to f of x. Here's my list. I always make a list, right? I want f prime of x. Well, if f of x is f of x, f prime of x is f prime of x. X prime at x, sorry. And then we need a g of x, which is our bottom function, and it happens to be x. And we need its derivative, which happens to be 1, right? Because the first derivative of x is just 1. So this is kind of weird, but it does build out pretty well. We take our bottom function times the derivative of our top function. And the derivative of f of x, we said, is f prime at x. Quotient rule says that we subtract, and then we take the top function, which is f of x, times the derivative of the bottom function, and the derivative of x is just 1, so it doesn't change anything, but I thought I'd show it to you, times the bottom function, over the bottom function squared, which is just this. And this is our h prime at x. So in this case, there's not much you can do to simplify this, so I hope this is helpful. In this case, remember that they're using this abstract example, just theoretically, what would you do? So there it is. If you have any questions or comments, please let me know. And if you haven't already subscribed, please do. Appreciate it.